Thank you so much, James, for this lecture. It was profound. I'm sure people have a lot of questions to ask. If you wish to ask a question, please put it on the chat. You can send it to either Royce, myself, or James himself. Royce, you have something to say?
Yes, there are a few questions they have already sent while they registered. I would like to put that before James. There's this question, practically, how do we connect Bible and maths also with other subjects?
Regarding integration, just look at the meaning of the word. It means whole. In other words, we want a holistic view, not a shalom. Hebrew shalom, it brings order and peace and structure. So what tends to happen in our math instruction is that we just take parts and just go from one part to the other part. And there's hardly any identifiable connection to it.
Mm.
So like when I teach algebra, there's a whole gamut of arithmetical operations you must have already mastered to be able to be successful in algebra. And if you haven't mastered the arithmetical operations, you will be lost in algebra. So you see, that's the connection, the whole, how everything fits together. Now, growing up in the Christian education world starting in the late 1970s, we first decided that the way we can connect the Bible to math is we just add Bible verses to our math lessons. That's the way it was. That's the way it started. Let's do math for God's glory, and then we count 1, 2, 3, 4, 5. Okay. Well, as you can see from what I was saying today, perichoresis is the ground. Look for connections.
Mm.
All right. And once you see who God is, and then you begin to look at creation in that light, you'll be looking for connections, both in how our inner world works, how mathematics connects within itself, and how we think about math, and also how math connects to the world outside of us. So you're looking at, that's your biblical approach, because the Bible does what? It reveals who God is. You just can't pull Bible verses out, so now we're doing Christian math. If you don't have a Trinitarian dynamics as the grounding to it, you're not doing math in the context of who you are in Christ, who God is in his Trinitarian relations, and how the creation reveals in an approximate way the nature and reality of the dynamic relationship between the Father, Son, and Spirit. That's how I'd answer it.
Thank you, James. Yeah. There's another question which says, how can I encourage and guide my child to regularly learn, practice, and do maths?
Uh, can I just add something, kind of summarize what you just said, James? You are saying that instead of adding verses, sticking verses onto the lesson of math, we look at it from the perspective of Trinitarian perspective, and in that we make connections rather than just stick verses and teach.
Right.
How would that look like? Can you give an example of how that would look like, say, in a topic like addition, simple as addition?
Well, you use the Fibonacci sequence as an example. When you're teaching addition, you're adding those numbers to get the next number in the Fibonacci sequence. So that you get them to learn their addition facts. You go 13 plus A is 21, 21 plus 13, 34. Then you get 55. All right. And now, from that, let's look at flowers. Let's look at the sunflower. Look at the spirals in a sunflower. They're double spirals, one spiral going one way and the other going the other way. Let's count how many spirals there are. And oh, wow, 8 one way and 13 another way. Isn't that amazing? So you see the connections. So when you're doing your sums,
Yeah.
you're actually connecting it to what to counting in the real world. And it starts not just with spirals, it starts with, everyday, and you can't exist without counting things. It's in terms of this living, identifying numbers and understanding what these numbers mean. Are these numbers identifiers, like in house numbers, or are they actually counting something? So that's you naturally connected. So what you have to do is you have to engage in exploration of space and number in the world in which the student is engaged with.
So intentionally look at maths from the perspective of exploring rather than rote memory.
And the memory comes from exploring. Of course, there are many different ways you can teach quick ways to add and quick ways to subtract. So another way to do it is to teach those shortcuts. So the student looks at an addition problem, all right, and says, okay, instead of doing 89 plus 38, let's do 90 plus 38. That's 128. Well, that's one too much. So 127. That kind of stuff. So you investigate the problem. Is there an efficient shortcut? And it's all dealing with mental math. So you have to develop the ability of being able to see things mentally and then not just resort to the pushing buttons in the calculator.
Just one more kind of an observation that doesn't that make the focus being mastery than an experience?
They both go together. Both experience and then mastery develops from experience. And once you have mastery, not just rote mastery, but mastery that's developed with fun behind it. How do I find patterns to make things easier to do? Then you have enjoyment, because students like to discover good ways to do things. They like exploring, they like investigating. So, they like the aha moment. So that aha moment just generates mastery. And the mastery is no longer drudgery.
Yeah.
Even learning your multiplication facts, you look at patterns to make it easier. Like, when you multiply by 2, you just double. 2 times 6, you double the 6. 6 plus 6, 12. If you want to multiply by 4, you double the double. So there's shortcut ways to do things.
How can a teacher develop a way of looking at things in this way? Because maths, because usually we hate the subject maths because of the teacher, because of the way it is communicated to us. So how as a teacher,
that is a problem. That's a problem. So it has to start someplace. So if our experience in math education is poor, we have to individually, as either parents or teachers, is to retrain ourselves. And so there are a multiplicity of resources that can help us retrain ourselves. What I've written will help. If you walk through my library, as you can see in the background, I have all kinds of resources that helps you retrain yourself. So you have to invest as a teacher to see what's out there and to engage in it and to learn. And as you are learning as a teacher, as a parent, then the child will pick up on it because you're learning things afresh. And then they're seeing you learn things afresh.
Thank you. That's helpful.
Thank you. Yeah. I remember you put a lot of stories of mathematicians in your book. How do you think it will impact the way we teach mathematics to our kids?
Well, mathematicians are people too, They're human beings like us. They have their frailties and their issues, their problems and their successes. And so you learn a lot about life from investigating the lives of mathematicians. And especially if these mathematicians have caught on to how creation reveals God's glory, like Johannes Kepler, He would write all these mathematical equations about the planetary motions, and he was so overcome by those motions and how math described them. He said, "Oh, there's a dance. I see God's signature there. It's there." And so his response was, he'd write a psalm of praise right there in his books. It's right there. Great is the Lord, great are your works. And so that's what you learn when you study. Now, when I discovered that Kepler wrote psalms of praise as a result of his math equations, well, no one ever taught me that in school. That was ignored or not even known. So you have to dig that out by investigating their biography.
Thank you.
Regarding helping a child learn, you encourage exploration, you help them identify shapes, you have them count things, you encourage them to learn how to see and identify patterns. And so that's where you start. You start with the concrete, what they see. And then when they start doing 2 + 2 = 4, instead of looking at 2 apples and 2 apples, they're just looking at 2 and 2. So that's a level 1 abstraction. That's a big step.
Mm-hmm.
To go from what you see and what you touch and feel to mentally engaging in that with an abstraction and writing it out. So that's abstraction level number 1, big step. The next big step is algebra, which is another level deeper, because now you're abstracting an abstraction. You're going from 1 apple to the number 1 abstraction. You write the number 1. And then in algebra, you say, let X be a number. So you have 2 levels. And you have to build up to that very carefully and slowly so the child is not overwhelmed by it.
Yeah.
Go
So
ahead.
you mean to say initially younger kids work with the concrete like apple and while counting rather than just teach them abstract numbers and slowly
Right.
from concrete to the abstract
Mm-hmm.
the algebra and so where they will be able to what is the age group you think the transition should happen from concrete arithmetic teaching to the algebra because sometimes we as parents or teachers like to bring algebra before even they have mastered the arithmetic.
Yeah, you don't want to do that. Never do that. Never engage in algebra without a mastery of arithmetic because that's a lost cause because you get students coming out of algebra saying, I hate math because of it. Because they don't know what's going on because they haven't mastered the arithmetic. So if you cookie cut like our education system does, okay, at age 6, you have to do this. And at age 8, you do that. Everybody does the same thing. Well, you're not paying attention to individuality. Every student goes at different paces. So you find in many classrooms, you find students that are kind of average, students that are behind, and students that are advanced. And so the advanced students want to carry on and learn more. They're bored stiff by the class because the teacher's teaching to the lowest denominator. The ones that are behind. And in the middle, the people in the middle kind of get, oh, what's going on? Da, 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 da. So there's a problem with our structure of the way we do our instruction. Now, I think individualized instruction is the best because you go at your own pace and you learn as you can engage and process the material. Just some thoughts. It's really hard to do it in a classroom, to do it rightly.
Yeah.
Yeah. I know what it's like.
So there are some questions regarding the curriculum that you have created, James. So
Okay.
folks are asking where they can find more details, and someone asked, which age group does this curriculum cover? Yeah. Can
The
you?
details, unfortunately, it's hard to get it in India because of I use as my printer Amazon, so you'd have to order it from Amazon USA or Amazon UK. You can get it in the UK. We're working on getting it available in India, so that's how you get it. And my website, biblicalchristianworldview.net has all kinds of details about the curriculum. Some of the things I talked about today are talked about in more detail. And the age level, it's the only thing I require, because I start from square one. I start with counting and place value. So because I'm teaching left to right methods, I want to engage that process so that the student can enjoy arithmetic. Every time I teach these methods in my past instruction, the students become alive with it because they see it's so easy and efficient and fast and fun. All right. And they don't have to worry about borrowing and all that stuff that we do, they get confused with. And so I begin, you have to be able to, it's designed for independent study. So the student must be able to read comprehensively, be able to engage in reading a math text. So when I ask students, in my experience with students, is, do you ever read your math textbook? And they laugh at me. Read the math text? You gotta be kidding me. We just look at the solutions manuals in the back and see if we can figure out how to answer the homework. So nobody's reading the text. And to put it bluntly, the text isn't worth reading in the first place. All right. So the text has to be engaging the student. So if you look at what I've written, I've tried to engage the student from the get-go by reading text, looking at graphics, etc., seeing all these connections. But you have to be able to read and concentrate, which is difficult, at least in America, for American students to be able to read anything past a couple of lines. They get distracted because they're so visually oriented. So you have to work through that. And so I recommend age 12 to start with, 11, 10, 11, 12, and all the way up to, it'll take you 4 or 5 years to get through it based upon the pace. So up to 16 and 17, because it goes into pre-calculus concepts at the end. So you're starting with arithmetic, you're going through algebra, going through trig and geometry, and then pre-calculus concepts embedded throughout.
Just quickly, one more question, if I can add before we end. Okay. Someone's asking this, Sangeeta was asking about what you think about Montessori math. What are your thoughts?
Now, what they're doing there, they're using the different lengths. I don't want to call it sticks or blocks or whatever they're doing, and they're helping you see, the magnitude of a number like 2 and 3. That's concrete. It's not the concrete I'm talking about looking at the physical world outside of yourselves. So what Montessori math does is it kind of loses something in the too much concrete looking at the blocks, and then the abstract is kind of negated or delayed far too much because it carries it into some algebra. In algebra, you should not have to resort to, visualizing some of the stuff using blocks. All right. You can visualize a lot of algebra using geometry, as the ancient Babylonians did. They would visualize solving quadratic equations using geometry. That's what completing the square is all about. If you know anything about quadratic equations, complete the square, you're working with a square, that kind of stuff. And then algebra is about language. So how do I interpret an equation 2x plus 3 equals 6? What is it saying to me? All right. Not how do I do blocks, but what are those symbols saying to me? 2x plus 3. What's that telling me? I say I'm taking a number, multiplying by 2 and adding 3. But that's going to tell you exactly how to solve the problem. It's going to tell you how to solve for x. So within the equation, is the solution. So that's what you want to train the student to see. Because every equation is going to give you the method of solution. And it's not by rote, it's by observation and investigation. But then when you see the algebraic equation connecting to the physical world, that only adds wonder to everything, as we saw with the quadratic solution to finding the value of phi. And then you see that how it interpenetrates everything else that's out there.
There are some really good questions coming up, but I think it's quite late. Okay, Royce, would you like to? Is that a question that you want
No,
to
I'm
ask
just putting
before we?
some of the questions which have come in and which James had answered those questions. So I'm just
Okay,
putting the question and answer. If they can copy paste and keep it and read it later, it'll be
yeah.
helpful for them. Yeah.
So if
So
you have any other questions that haven't been answered, they can always communicate to me via Royce
yes, we'll do
or
that. There are some really good questions that we would like to ask you and send those answers to the
okay.
participants. Um, okay, Royce, is there
Yes.
anything that you would like to end with?
Hmm. I think that's all. If anyone is interested in James' book or curriculum, you can just message me and I'll let him know that this is the need, this is the number of books that is required. And we're working on something to be published on demand in India and hope that this materializes soon. And it will be very helpful for us people in India. Thank you so much, James, and thank you all of you for joining. And just bless you. And we continue this webinar every month on the 3rd. We will let you know which is the topic that is we're going to come up with next month. So be tuned to that. Thank you.
Thank you. Thank you, James, for coming in. Thank you so much for your talk.
It was my pleasure.
Thank you. Thank you, everyone, for joining.